All right, let's hit this pretty tough worksheet here. Okay, so let's look at question 1, and it's a very similar problem to the first question in worksheet 5. Graph of a cubic function f, so we don't know what the function actually is, but it has a local maximum there, local min there. Values of c such that the equation f of x, i.e. the cubic, plus c, so plus this constant value here, which is a vertical translation, has exactly one solution. So really, really similar to the last worksheet. So a, -3, we're going to say that that's a local maximum. B, -8, it's a local minimum. You might think, how'd you know they were there? Well, I don't. This is just a guess that they're in those positions. They could both be there. I think they can be switched around as well. It doesn't matter where these mins are because it's being translated. And I think wherever or however you draw this, so this one's going to be a positive cubic, but if you drew a negative cubic, this would work equally. All right, so exactly one solution. So C equals 0 at the moment is actually, that's a working solution, okay, because that gives us one x-intercept or one solution. And actually C could go as high as 3, not including, so I could bump it up 3 more units, and this would still only be the one solution. So C less than 3 would work, okay? So any value of C less than 3 would work nicely. Like if it was -10, it's just going to get lower and lower and lower, okay? And we're still going to get the one solution over here. Now, what can happen though is if we continue to bring it up, okay, we could bring it up higher and higher and higher. Okay, so we could bring it up 3 and it will get to there, one solution. But if we keep sending it up, okay, and we raise C above 8 units, what will happen is the bump, or this bump will come up to here, okay? Now, then we'll get like a local maximum somewhere up there, 8 units higher than it is there, and one solution will be over here, okay, when this is raised more than 8 units, okay? So our answer will be C less than 3, C greater than 8. There it is there. All right, this one here, tech active as well, so that's good. Part of the track, so we got like this super train, okay? A part of the track for Tim's model train follows the curve passing through several coordinates above, or several points. Tim has designed it by putting axes on the drawing. The track is made up of 2 separate curves, one to the left, one to the right. So this would be like curve 1, this would be curve 2. B is the point 0.07. And curve B to F is part of the graph of a cubic function, P, Q, R, and S, and the gradient at 0. So the gradient at this point here is 4.25. Okay, don't know why they're telling us that. This one is pretty clear straight away. So the first question is to show that S is equal to 7. Right, so how are we going to show it? Well, what I know here is if I put 0 into the function, the answer is going to be 7. Okay, so let's do f of 0, and it is p 0 cubed plus q 0 squared. Now I know that that's 0 and that's 0, but this is show that, so I'm going to show that I'm doing the substitution, plus r times 0, we know that that's 0, but to show that, plus s. So f of 0 equals s. Now what does that tell us? F of 0 is 7, f of 0 is s, therefore s must equal 7. Okay, show that r is equal to 4.25. How are we going to do that? R is equal to 4.25. So for this one here, what we might do is we'll use the second piece of information that we're given, which is f-0 equals 4.25. So I'm just trying something here. We're going to get the derivative of this function here. So we'll get f-x equals 3px squared plus 2qx plus r. And we're going to note that f-0 equals 4.25 from the information. So we'll do f-0 equals 3p0 squared plus 2q0 plus r. f-0 equals r. f-0 equals 4.25. Therefore, r equals 4.25. The furthest point reached by the track in the positive y direction occurs when x is equal to 1. Assume p is greater than 0. Use this information to find q in terms of p. All right. So this is the furthest point in the positive direction. All right, you can see that that's not the furthest point. This is the furthest point. So that occurs at x equal 1. And we don't know what the y value is, but I do know that that's a stationary point. Now, the fact that that's a stationary point means I think the derivative will probably be involved. Okay, so what we'll do is we'll use the derivative. So f dash x is equal to qp 3p x squared plus 2qx plus 17 on 4. All right, now what we're going to do is we're going to say that f-x is going to be 0 when x is equal to 1, because the gradient is 0 when x is 1. So that's going to be 3p. Now notice I'm not showing the substitution here because it's not a show that, plus 2q plus 17 on 4. Okay, we're in business now. So P and Q. So sometimes I don't actually know where this question's going sometimes before doing it. I just try it out and see what happens. And actually P and Q have come out as the only two unknowns, and we need to find or use the information to find Q in terms of P. So this is good. All right, so we're going to say that 2Q is equal to negative 17 on 4, take 3P. Q is equal to negative 17 on 8, take away 3p on 2. I've divided both sides by 2 there. Okay. Find f of 1 in terms of p. All right, so what we're going to do is note that my function, so let's note what my function was. There it is up there. So f of x, this will be on like a double page spread in your exam. So you'll be able to sort of just look straight across or look slightly to the left and you should see your function. Px cubed plus qx squared plus 17x on 4 because I've worked out what r is plus 7. Okay, so I know what r and s is. They've given me that information previously. Okay. So we need to find f of 1 in terms of p. Now notice it's not going to let me use or put q in it. And if I do f of 1 at this point here, I'm going to get like a p and a q in my answer. That's not good. Now, how can I get rid of this q? Well, it just so happens, and this is never an accident in methods, so they got us in the previous question to find q in terms of p. So what I'm going to do is simply do f of 1 equals p1 cubed plus, and instead of writing q here, what I'm going to do is write what q actually is, which is negative 17 on 8, take away 3p on 2. X squared is simply 1 squared, which is 1, plus 17 on 4 plus 7. All right, now I haven't used the calculator yet, but I'm not going to do that thing by hand. So I'm going to go over here and I'm going to go, I've got P plus negative 17 on 8, take away 3P over 2 times 1 squared is just times 1, plus 17 on 4, because I'm putting 1 in there, plus 7. And I get negative P on 2 plus 73 on 8. All right. Find the value of A in terms of P for which f dash A equals 0. Find the value of A in terms of P. All right, so what we're going to do here is, so f dash x is equal to 3p plus 2q, 3p x squared plus 2q x plus 17 on 4. Okay, now what we're going to do is we're going to get f dash a, which I know is 0, equals 3p a squared plus 2qa plus 17 on 4. Okay, so I already know what q is. So I'm going to do 0 equals 3pa squared plus 2 lots of whatever q was, which is negative 17 on 8. Take away 3p on 2. 2 times that a plus 17 on 4. So find the value of a in terms of p. A, p are the only two variables. Good, we're in business. So at this point here, I'm going to jump over to my calc and say solve 3p a squared plus 2 lots of negative 17 on 8, take away 3p over 2 times a plus 17 on 4, and we want to solve the value of a, so solve for a. So we've got two possible solutions. So one of the solutions is a equals 1. The other solution is 17 on 12p, but a greater than 0. A is greater than 1 according to the information in the question. Therefore, a equals 17 over 12p. If a is equal to 17 on 3, show that p is a quarter and q is negative 2.5. All right. So a is equal to 17 on 3. So 17 on 3 equals, let's go with this one here and use that information. So a, I'm just going to replace a with 17 on 3, 17 on 12p. Okay, so how are we going to do this? 12p times 17 equals 17 times 3. So I've just cross multiplied there. Now what I'm going to do is divide both sides by 17, which will cancel that 17 and that 17. 12p equals 3, p equals 3 on 12, p equals 0.25. Okay, now that's p taken care of. Q, now how are we going to get q? Okay, so Q, we've already got a definition of Q up there. So Q is equal to negative 17 on 8 take away 3p over 2. So we're going to say that Q equals negative 17 on 8 take away 3 times 0.25 over 2. Q equals, so just going to grab this portion here and do with P equals 1 over 4 and Q equals negative 5 on 2. So there's Q and there's P. Okay, so more than any question, I think this one here has just got so much related information. Right, for the following, assume that f of x, so that cubic function is this function here. Okay, find the exact coordinates of D and F. D and F, they're just the solutions. And because we're going to assume that we're using this from now on, that's going to be relevant for C, D, and E. I'm now going to define f of x equals 0.25x cubed, take away 2.5x squared plus 4.25 plus 4.25x plus 7. Let's just have a look at it. Whoops. That looks all above board. All right, find the exact coordinates. So what I'm going to do is solve f of x for 0 for x, and we've got those 3 possible solutions. So I'm just going to note that I've done f of x equals 0, and x is equal to negative 1, x is equal to 4, and x is equal to 7. But D and F are greater than 0. If we can have a look at my original picture, you can see that D and F are greater than 0. So let's chuck this solution here. Therefore, x equals 4, x is equal to 7. And let's list them as the exact coordinates. So 4, 0, 7, 0. Find the greatest distance that the track is from the x-axis when it is below the x-axis, corrected 2 decimal places. That's this point here, point E. So what we're going to do is diff f of x, and let's see what happens from there. So I'm going to find f dash x equals, I'm going to diff it on my calculator. Diff gives me that. Okay, so I'm going to note that down. It is 3x squared take 20x plus 17 all over 4. Watch those vinculums there, make sure they go all the way across. And we're going to go 0 equals 3x squared take 20x plus 17 all over 4. So on the calc, we'll just do a solve. Ants equals 0, comma x. Now remember, ants can be found by doing shift and execute. So x is equal to 1, x is equal to 17 on 3. Now we know that x is going to be greater than 1 rather. So we're going to say but x greater than 1 for min. Therefore, x is equal to 17 on 3. Now what we'll do is we'll stick that into the original function. So let's find out what or how far it is by doing f of 17 on 3. Negative 100 on 27. Therefore, negative 100 on 27 units. Find the greatest distance the track is from the x-axis. I wonder if they'll accept the negative answer. Okay, let's not do that. And it's got to be correct to 2 decimal places as well. Okay, so what we're going to say here, we'll go shift, no, we'll go decimal and get the approximation. So we're going to say that the answer is 3.70 units from x-axis. Right, so noting that even though it's negative, it's 3.70 units from the x-axis. All right, last question. Okay, the curve from A to B, so this will be the left-hand part of the function, is g of x equals where A and B are positive real constants. The track passes smoothly from one section of the track to the other at B. That is, the gradients are equal at B. Find the exact values of A and B. Okay, so where does the join happen? The join happens at this point here. And from this information here, I know that the gradient at the join is 4.25. So that's what we know. So that we know for g of x, that point is going to be true. And the gradient, because it has to be the same as the other function, the gradient has to be 4.25 at that point. Okay. So what we're going to do is, so we're going to say that 7 equals g of 0 equals a over 1 take bx, so b times 0. So that's going to be 7 equals a over 1. A must be 7. Okay, so now what we're going to do is note our function is g of x equals 1 over 1 take bx. Let's get g dash x equals, so to do that, I'm going to define g of x equals shift divide. Why did I write that down as 1? That should be 7. So just correcting notes here, that should be 7. So we're going to go 7 over 1 take bx. Okay, let's diff it. Diff g of x is, I'm writing at the bottom of the pen there, 7b over bx take 1 all squared. Okay, and let's use this information here. So I'm going to say 4.25 equals 7b over bx, that's going to be 0, negative 1, 0, take 1 is 1, that's going to be 1. Okay, that's going to give us 4.25 equals b, so we're going to divide that by 7. So let's jump on our calculator and go 4.25 divided by 7. B is equal to 17 on 28. Whew. Okay, so that's not an easy question. There's a lot of thinking with that one there. But, you know, fantastic polynomials question. I mean, it's just basic polynomials and derivatives. That's all that is. I mean, that you could, you know, in theory do that right now, but you can just see how sort of how much VCAR certainly up the ante with problems like this. All right, so I hope that was helpful, and I hope that it gives you some ideas, and also, you know, want to emphasize here the importance of continuity of questions, that all of these parts are interrelated, that when you find one value, you're probably going to use it somewhere else.